Let's get some practice finding the probabilities underneath normal distributions. So the only way that you can find the probabilities underneath smooth normal distributions is either with calculus, but because we don't know calculus yet, we have to give ourselves a table. So we're going to give ourselves a table that gives me a bunch of these values on our x-axis, and then it's going to give us corresponding areas to the left of those points. So let's answer this question. We've consistently said throughout this text that data is significant if it is further from the average than 2 standard deviations. So if the z-score is bigger than 2, what is the probability of having a z-score greater than 2? So anytime you're asked for finding the probabilities underneath a normal distribution, draw the normal distribution. You always need to give yourself a picture to look at. So if we're looking at z-scores, and I want to find the probability of having a z-score greater than 2, the average z-score is 0. This is a standard normal distribution. The standard deviation is 1. So if right there is 0, then 2 is somewhere to the right. Right, you're 2 standard deviations away. And I want to find the probability of being more than 2 standard deviations away. So I want to find this area right here, right? Again, probabilities are areas underneath probability distributions. So let's answer this question. What is that area? So this area is the probability of having a z-score greater than 2. So let's figure out how to read this. We need to read our z-score chart. So this is the chart that we're going to use, and there's a lot of different charts available. You can find different ones online if you would like, but all of these values inside this table are going to be approximations to what we need. Now, if you look carefully up at the top of this graphic depicts exactly what these values are. All of these values gives you the areas to the left of certain z values. Okay. So let's just go through a small example first. Let's look at the z-score, I don't know, maybe 1.63. So again, this graphic tells you exactly what this table gives you. It gives you the area or the probability of having a z-score less than 1.63. So 1.63 is further to the right. So our picture makes sense here. We're looking for the z-score of 1.63. Let's go through our table. So in red are your z-scores. Go down until you find 1.6. And then you're going to go over until you find 1.63. So this box right here. So their intersection, that's the right z-score. That's the area to the left of the z-score 1.63. So 94.84%. 94.84%. Remember, the red here are the z-scores. Those are on our x-axis. The values inside this table gives you the areas to the left of those z-scores. Okay, so now that we know how to read this table, let's go back to the original problem that we were working on. We were initially charged with finding the area to the right of 2. So again, this table is not areas to the right of points. This is areas to the left of points. But we can use what we know from probability distributions to solve. So we're interested in the z-score of 2. Let's find that. So go through your z-scores and look for 2.0. And then it's going to be this first column, because we want exactly 2. We want 2.00. So their intersection gives me this value right here, 97.72%. So let's go to our picture. If the z-score is 2, then this area is 97.72%. And we wanted this area. Well, if this is a probability distribution, then the area underneath the whole thing has to be 1. And if there's 97.72% here, the area to the right of 2 has to be 1 minus 97.72%. And if you run through this, you get 0.0228 or 2.28%. So we used our table to find the areas to the left of the positive z-score, and then we used what we know about probability distributions to find the area to the right. So this is why it's so important to draw the picture every single time. So the probability of having a z-score greater than 2, that's the exact same thing as the area underneath this distribution on the right side of 2, right? I can't drill it in enough. Areas underneath probability distributions are the probabilities that you're interested in. So the probability of having a z-score greater than 2 is 2.28%.